All right, so although in question 3 we could use a boatload of product rules, that would not be fun. I mean, it might be fun. I don't know what the hell you do for fun nowadays, but this would be kind of tedious. I think that's a better word. So notice that we have a lot of things multiplied together. This is a perfect situation for us to use logs. So again, if I take the natural log of both sides, I'm going to get the natural log of this whole entire thing up top, this sinh e to the x, x squared sine of x. That whole thing is going to be what we're taking the natural log of. So natural log has this really nice property that each of these terms is going to end up being added. All right, so we just get a whole bunch of now added terms instead of multiplied terms. So we set natural log of y. Same idea, we can take the derivative of both sides now. So if you're going to use logarithmic differentiation, you better know how to take derivatives of natural logs quickly. All right, so this is going to be 1 over y dy dx, as always. All right, so the chain rule for natural logs is whatever's in the argument, in this case sinh, is just going to get dropped to the denominator. So we're going to have a sinh down here. And then we just take the derivative of whatever's in the argument. So the derivative of sinh is going to be cosh. You could use the product rule, the chain rule here, but you could also recognize that the natural log of e to the x is just x, right? So that's going to give you 1. If you were to actually do this using log rules, you would get e to the x in the denominator divided by the derivative of e to the x, which is still e to the x, so that's still going to give you 1, right? So either way you do it, you're going to get 1. And we have plus the natural log, I don't know what the hell that symbol is, plus the natural log of x squared. So the x squared is going to come down to the denominator. We're going to take the derivative of x squared, which is just 2x, right? And we're going to get a cancellation here. X and x is going to cancel, so that's just 2 over x. And then finally, at the end, we have sine of x in the bottom. Derivative of sine is cosine, so cosine of x in the top. We can clean that up a lot, so I'm going to kind of cheat a little bit because watching the videos, if you want me to like plug in things for y. So multiplying everything by y would be y was the sinh of x times e to the x, x squared sine of x. This whole thing is going to be cosh over sinh. I'm just going to write that as a tanh plus 1 plus 2 over x cosine of a sine. That's a cotangent of x. That would be our derivative. Yeah, that's the derivative.